over the last couple, 3 years, we've actually been reoriented our business at GE Intelligent Platforms inside of GE to really be single-mindedly focused on making the benefits of the industrial internet real for customers. Now, for us, there's two customer constituencies. The first thing is GE as an OEM, probably a consumer of about $500 million a year of controls. So we consume that much ourselves, and then we provide the exact same technology to the outside world. And we really see that journey as this notion of sort of connected machines, providing, connected to analytics, providing insights that allow people to do better work. And what's amazing to me is if you think about the last 2-3 years, I've been in the automation industry for 20 plus. Probably the most exciting, fast transformation I have witnessed during my career. And just by way of context, when we did the first sort of PROFINET forum a couple of years ago, we were talking about this notion that one can start leveraging technologies that were originally developed for the commercial internet into the automation world. And frankly, we were at a stage there where the acceptance of that concept was still being discussed. And if you fast forward to today, if I told you that story, it wouldn't be particularly entertaining, right? I mean, absolutely every vendor out there, including ourselves, is actually touting the Internet of Things and how it actually allows us to have higher productivity, higher uptime, et cetera, et cetera, et cetera. So what I thought I'd do in the next few minutes is actually share with you a little bit of the GE journey in terms of adopting some of that technology for the last 2-3 years, in the spirit that actually may help you as you try to do the same in your businesses. So for us, at the GE level, we're actually full in. From our CEO down, we really see this notion of connected world or Internet of Things as a key enabler for the next generation of productivity for our customers. We're actually embedding this technology into everything we make, from gas turbines to compressors to wellhead to medical equipment. And really, what we're after is how do we actually grab real-time data off the machine as it's running, aggregate it as a fleet, and with that get smart to be able to provide customers with new levels of insight on how to just run that equipment with higher uptime and more efficiently. And the reality is, if you really think about it, just the value, there's value to be had by doing that. There's some interesting metrics at the top on this slide. But if you really think about, your control systems today collect millions of data points, no matter really independent of what process you're actually running. And we look at, hey, there's value to be extracted by owning the data in those control systems. There's value to be extracted by sharing it, and there's value to be extracting by selling that data. So let me just go through a little bit more of those things by way of example. If you have access to the data of how your system is running, and these are some McKinsey study numbers in the oil and gas industry, you typically get about a 20% competitive advantage in development cycle of your next generation product. I mean, that's meaningful, right? If you are able to share live data between how your machines are operating, particularly if you're an OEM, according to the study, your support costs are typically reduced by about 40% over a non-real-time sharing model. And what's interesting is that on top of that, you can provide your customer with a better experience. So it's a bit of a double benefit there. And the third one is really connected world or massive connectivity has an opportunity to just create new service models around your equipment. I talked a little bit earlier about what GE is doing in that regard as an asset supplier, and we're actually seeing the same thing happen with many of our OEM customers out there. So let me talk a little bit more about some concrete examples of these. So I'm going to go through three examples of how this industrial internet is actually creating value for us, or how we're getting value out of that. And we'll focus a little bit on what are we doing to use it to improve asset performance. What are we actually doing to change the customer experience, and what are we actually doing to enable new service models to see how those work for you. So the first example I have is around asset performance. We run a site out of Chicago. We're actually monitoring about 5,000 assets from multiple vendors. I mean, not just GE assets, multiple vendors across primarily oil and gas and the power industry. We can typically give our customers through this massive connectivity about a 6-week advance warning if a major piece of equipment is going to fail. So we can actually tell Mr. Customer, you may want to consider shutting down your turbine because in 6 weeks, the third blade on the second row is likely to break down. That's going to become expensive. And really that's done on one location for a distributed fleet that extends a multi-vendor, and where the assets are everywhere from Russia through to North America, through South America to the Middle East, right? From a single location. An engineer today works on doing this kind of advanced prognostics regardless of asset brand and regardless of location. So this is actually real stuff. We have a nice little thing where our engineers have a contest for what they call catch of the week, which is who actually detects the highest value potential failure before it happens, as validated by a customer. So I use that color just to say that, hey, this value is there, and I think OEMs out there really have the opportunity to just go create the same type of semi capability. The second one is really an example of us utilizing sort of connected world technology to enhance the performance of our own assets. The specific example on the screen is purely the consequence of us detecting an opportunity to just go to make a software change that actually saved us about $30 million in reinstall costs, just basically by being able to remote into a fleet of wind turbines. So these are big numbers, right? I mean, this is people notice $30 million. Even at GE, which is a large company, people notice $30 million checks. It's a big number. And really, the third example is a little bit about how we're actually doing the same and now taking this exact same infrastructure, from the controller all the way up to the prognostics and making it available as a package to OEMs so they can go do it in turn. I mean, this is actually today available from us. I know it's available from others. But I thought these were three examples that would sort of illustrate that this idea of Internet of Things is not something you just read on the paper. This is something that people are making real money on today, right? I mean, we're making money as a service provider here. We're making money by providing better asks to our customers when you think about GE as an OEM, and obviously we're enabling it technology. So I think if it applies to us, it probably applies to most people in the room as well. And really the time to go do something is now for people that want to stay competitive. So what have we actually learned in the process of doing that? So I wanted to share three GE learnings as we went on this journey from the traditional way of doing things to this Internet of Things mindset of things. And the way I would describe these things, number one is architecture matters. I like Mike's word, right? This idea of highly distributed controls are really the vehicle by which you combine flexibility and standardization. You need standardization for massive deployments, and it doesn't really matter whether you're running an assembly plant or you're deploying 20,000 wells a year. That standardization matters, but you need flexibility to go with that, because otherwise the value that we were talking about is really hard to realize. The second one is that with new business models come, you have to learn fast what variation of that new business model is going to work for you. So I'll share a little bit about our journey on that path. And the third one is this notion that in this connected world, increasingly a better answer lies outside of the doors of your own place. And so I'll share some GE examples around collaboration. Right? So we talk about, I'll talk about three things on architecture matters. Number one is, as we looked at the GE level, what does the platform have to look like for the Internet of Things? We basically took hey, you have to sort of redo from scratch kind of approach. Over the last 2.5 years, a little bit like our colleagues at Siemens, we spent over $1 billion in Silicon Valley building a platform for this industrial Internet, just because the needs around what you're trying to do are just so different, right? When you think about big data, when you think about the fact that we collect way more data than a Google can collect just because of the intensity of per second info out of most assets, how do you just go architect for that? When you think about access anywhere on mobile, how do you architect for that? When you think about doing that in a secure way, how do you architect from that? So we really identified about 7 different premises that had to be there in a platform for this connected world, and then engineered for that. If I deep dive a little bit into what we call transition to brilliant machines, and for us, brilliant machines are machines that can actually just change their behavior over time without or with minimal human intervention, right? We really saw a combination of two things. Number one is when people think about controlling these assets, they still ask for the traditional things, right? Everybody still cares about uptime, performance, longevity, engineering productivity, and want it for free, right? That's sort of the basics. But on top of that, there's an increasing demand for a set of new capabilities. Number one is this notion of on-machine storage, on-machine analytics. The second is this notion of seamless device to cloud connectivity. And the third one is this idea of embedded analytics. So how do you actually just go do that on a control system that still has the same constraints that the traditional one we had? And the way we've actually thought about this thing architecturally is really with 3 very, very simple premises. And actually, it's interesting that they're actually very similar to what Mike was describing in the automotive industry. Number one is Ethernet as a new backplane. We talked about this a couple of years ago. That's it. If everything to everything over an Ethernet wire. Number two, standard protocols. And we actually picked PROFINET as our I/O connection protocol for much the same reasons that you actually saw earlier in the presentation. It's a combination of performance, robustness, and ecosystem availability out there. And the third element is this notion of really taking advantage of high computing power. If you think about our industry, and if you just play a Moore's law of how much of the CPU power has been made available at the point of control, we thought there was opportunities in there. So we actually started thinking very differently about how we do those three things. So, and like Mike said before, really our platform across the board today is really leveraging PROFINET as its backbone for connectivity. And actually, just to give you a non-GE view, from a customer perspective, this stuff works. I mean, here's an example for FMG. FMG is a large miner in Australia. And what I thought was interesting in here is they felt that in their particular case, the key benefit was the notion that, hey, on a PROFINET architecture, I can go out there and my ability to safely do live changes on a very highly distributed system are just unlike anything that actually has been done before. So it works a lot better when a customer says that when I said it. But I find it interesting, right? System is robust, reliable, and I would strongly recommend making this the default architecture for remote I/O. As a sign of high regard on site for this network when working on a live plant, engineers were happy to isolate blah 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 to do maintenance while conveyors were in operation using remote I/O. Now conveyors in a mine actually carry heavy stuff that really hurts when it breaks, right? So that's actually big words for the type of reliability you can achieve here. So second item, so the first item is architecture matters, and we've actually made significant investments there. The second item is this notion of with this sort of Internet of Things world comes a different set of business models. And what we actually found inside of our company, we're a large company, we're an old company, is that in order for us to be able to figure out how you can make money here, you have to be willing to experiment at a very fast pace, and you have to be willing to try things out and then move them to the back and try something different out. Now, we gave this framework, internally we call it FastWorks. It's really inspired by some of the Silicon Valley, startup technology, and we're actually adopting those inside of the GE business. So sort of our second learning is probably the way you think about the business model in that highly connected world initially is not necessarily going to work. So do you actually have a mechanism in your own business that allows you to just fast turn that to something that actually is meaningful? And we're finding that actually works very well for us. Now, if you have a 20-year-old mature product that you can just sell without thinking, probably not very applicable. But if you're trying to figure out new ways of monetizing things like the Internet of Things, we find that this actually works really, really well. And the third one is, and this actually, as you can imagine, for a company like ours, it was not particularly natural. It's sort of becoming comfortable with the idea that the better answer sometimes may lie outside of the walls of your own enterprise. So I'll share with you how we are actually using at GE this concept of open innovation by using essentially publicly available sharing / collaboration type platforms. We're doing this thing across all of our businesses. So we're doing this thing in aviation, we're doing this thing in energy management, which is my division. We're doing it for healthcare, oil and gas, and power. We actually have been running these things we actually call quests, and our innovation quests are really open requests to the community with really very limited restriction to go and solve a problem in a better way than what we could do ourselves. Now the numbers are actually quite interesting. Typically a quest lasts about 3 months. We've actually had over 120,000 people engage in some way or another on some of these quests across really the entire globe. 160 plus countries, 500 plus cities by now. And so really what we do is we throw out, hey, listen, here's a particular problem. Are you interested in helping us solve it? And I'll give you a couple of anecdotes in terms of the type of results that you can get with this type of thing. And I'll talk a little bit about the flight quest and the engine bracket challenge. We actually threw out, now we are a $15 billion aviation supplier. I mean, we've been in this industry for a while. We think we know what we're doing there. We went out there and we actually threw out a quest using Kaggle, which is actually an open platform for shared innovation. And basically what third parties were able to find, for us, basically a predictive model that was 40% better than anything we actually had. And we consider ourselves to be a domain expert in this space. Look at the savings. Look at the savings per minute per airline on that kind of improvement. Just very, very significant, right? So the third element is how do you actually just go and integrate into your way of doing things the creative input of the world at large. The example on the right is very concrete and really, really interesting. We had a bracket as part of a turbine design, and we decided to go crowdsource that bracket. There's sort of two elements that are just absolutely eye-opening here. And the first one is that the winning entrant that came from outside of our company had with the exact same kind of strength and material properties, roughly weighed 84% less. Now, if you put things on an airplane, every pound you shave is worth a lot of money, right? The second thing that is just amazing is that the winning design came from a 20-year-old non-college graduate kid in the Philippines. So when I say think about leveraging the world at large, we really mean think about leveraging the world at large. Now, of course, because this thing goes on a plane, we just went out there and on top of that design did our traditional validation process and so on, because you really do not want us to just go build airplane parts off of random things. So, and we don't do that, so no need to worry. But the innovation, the notion of accelerating innovation by leveraging the world, we think is really the biggest transformative effect for the next 5 years. So, 3 years ago when we were actually talking about, hey, listen, start thinking about how you bridge the world of the commercial internet and the industrial internet. If I were to make a similar statement today, it would be around think about how you leverage the brains of the planet for your business, not just the brains of your business for your business to make a difference. So at the end, we are convinced, if 3 years ago we had a hypothesis, today we're actually convinced that really the brilliant machines are coming. We think brilliant machines are connected machines. And when we make a choice of connectivity, the choice that we made at GE is around doing that with PROFINET, really for the same reasons that multiple industries have chosen to do that. With that, let me just transition it over to someone that can tell you how this stuff really works. Okay, Dave?